In this video, we are going to see an application of linear algebra in balancing chemical equation. The balancing of chemical equation can be made much easier using the procedure what is explained here using linear algebra. The popular method of balancing an equation is by inspection. You make successive and intelligent guesses for the coefficients which will balance an equation and continue guessing until the balance is achieved. That is the usual procedure we use in chemistry. This is straightforward and speedy if the equation is simple. But if the equation is little complicated, then the procedure what we are going to see here employing the Gaussian elimination method in matrix algebra to balance the chemical equation will be an easy method to do. So if we have a chemical equation, it is an expression showing symbolic representation of the reactants, and the products are usually positioned on the left side and on the right side in a particular chemical reaction. Left side and right side are separated by a single arrow. It points towards the direction of the product, which indicates a one-way reaction. Mostly it is irreversible. Suppose if there is a double arrow pointing on either direction, it indicates the reversible reaction. So a chemical equation is said to be balanced provided that the number of atoms of each type on the left is the same as the number of atoms of the corresponding type on the right. To understand this, let us take this example. We know that the sodium hydroxide reacts with sulfuric acid and it yields sodium sulfate and water. That is NaOH plus H2SO3 will lead us to Na2SO4 plus H2O. So if it is taken as an equation, maybe we may have the sodium hydroxide plus the sulfuric acid yielding the sodium sulfate and water. So the chemical equation what we find here is not balanced. We would like to balance this equation. To balance this, let us insert the unknowns, say x, y, z and w. So let us say w times the sodium hydroxide plus x times that H2SO4 yields a coefficient of sodium sulfate Na2SO4 plus z times water, which is H2O. Now let us compare the number of sodiums, oxygen, hydrogen and sulfur on both sides of this equation. So we get the sodium on my left hand side is 1W and on my right hand side it is 2Y. So this must be balanced. And when I take oxygen, 1W plus 4X must be 4Y plus Z, and for the hydrogen it is W plus 2X equal to 2Z, and for sulfur you have 1X equal to 1Y. So if we rewrite these equations, we can say alternatively W plus 0x minus 2y plus 0z equal to 0. W plus 4x minus 4y minus z equal to 0. W plus 2x plus 0y minus 2z equal to 0. And 0w plus x minus y plus 0z equal to 0. So we have a system of four simultaneous equations in terms of these four unknowns w, x, y and z. So our aim is to solve for these unknowns w, x, y, z. We can use any method. Suppose if we are trying to use the Gauss elimination method, then we have to take the augmented matrix of this given system. So writing the equation of system in the matrix form, the augmented matrix will be the coefficients of w, x, y, z and the constants on that side. And if we are taking the reduced row echelon form of this, maybe even you can use your graphing calculator to get that. We get the equation, the matrix 1 0 0 negative 1 0 0 1 0 negative half 0 0 0 1 negative half 0 0 0 0 0 0. So the last row tells us that it has multiple solutions. So this is the augmented final reduced row echelon form of the augmented matrix. Now since Z is an arbitrary, we can take Z to be an arbitrary element. Since we are dealing with atoms, it is convenient to choose this Z to be a positive integer. Instead of taking Z equal to negative half, we can take Z to be negative half times T, Z equal to negative half times T, and the T if I'm taking to be say negative 4, then you will get Z equal to 2. So it is one such choice for Z. So if I take Z equal to 2, then the corresponding W, X and Y from this equation will be 2, 1 and 1. So using these values of X, Y, Z and W, you know that the unbalanced equation will transform into an equation 2 NaOH plus 1 H2SO4 gives us Na2SO4 plus 2 H2O. This is how we balance the equation. So what we did was we took the augmented matrix, we got the values for the unknown variable z. Z can be an infinite, it can be a parameter t, but t takes infinite number of values. So using that approximation, say z equal to 2, we got the values of x, y, z and w as given here, and this is an equation. So this type of Gauss elimination method allows average and even low achieving students a real chance at success. It can remove what is often a source of frustration and failure that turns students away from chemistry. Also, it allows the high achieving to become very fast and very accurate even with relatively difficult equations. A balancing technique based on augmented matrix as described in this work will be very useful for all those who are doing balancing the equation. Hope you enjoyed this technique of balancing chemical equation using the matrix method. Thank you for listening and thank you for watching.